Hello everyone and welcome back to the MAC project. In this session I will walk you through setting up our MuleSoft AI Chain Connector. I will focus on our latest release, which is version 0.3.0, available on our master branch. So I'll guide you through, first of all, getting the connector locally available on your machine. So we will clone the repository, we will install it locally. After that, we will import it into our Anypoint Studio project. So we will add it as a dependency, and then we will start configuring the connector. So I will show you the configuration steps. And as a last step, I will go through each individual operation that the connector is offering, so that you have a good understanding about the connector, how it works, and how to get started building your own agents. So I would say let's start with the very step one, and that's going to our GitHub repository. So the easiest way to get access to the GitHub repository is just go to mac-project AI, our website, and where you can find the GitHub icon in the header. Just click on it, it will route you to the GitHub organization, and you can just click on repositories where you will see public and private repositories. You will only have access to the public ones, so you can click on MuleSoft AI Chain Connector. We are here on the master branch, which is correct, and we can just click here on the link to the repository that we want to use. So I will do that. I have already a terminal open that points to my desktop. So I will just clone the repository directly into my desktop, and let's wait a couple of seconds for that to finish. So that looks fine. I will cd into the repository, and let's see what we have inside. And that looks fine. So we have the most important files here inside. Also the POM file that we need now for the next step, and that's triggering the builds and the installation of the connector so that we need it for our Anypoint Studio project. So how do you build and install the connector? That's also really easy. We can again go to our website, click on Docs, then on the MuleSoft AI Chain Connector section, how to get started, and here basically a really simple line that you can just copy for your terminal, and that's installing the connector. Very important, make sure that you follow all the requirements. For example, you can use Java JDK 8, 11 or 17. Make sure that this is available on your machine. Maven as well, and of course Anypoint Studio. In my case, let me see what Java version I'm using. Okay, I'm using at the moment Java JDK 8, which is completely fine. And I will just paste now this command, which is Maven clean install. And I want to skip the tests, which are now not required to trigger the build. So here we need to wait a couple of seconds. Perfect, that was already it. So now we have locally installed the connector into our Maven repository. So now as a next step, we will open Anypoint Studio and add it as a dependency into our project. So here you can see I have already opened Anypoint Studio. As a next step now, in order to import the project, we first of course need to create a project, and I will do that now. I will create a new project. You can just use any name. I will use MuleSoft AI Chain, MuleSoft AI Chain Connector. Keep it simple. In the POM file itself, we now need to provide the dependency, and I will of course copy paste it. Let me just go to the dependency section, add here the new dependency to the project. So the group ID is com.mule.mulechain. Artifact ID is mulechain AI connector. The version is 0.3.0. That's the one that we just downloaded and installed from the GitHub repository, from the master branch, and by default for all connectors, the classifier, which is Mule plugin. Okay, so if you add this, then you are good to go. Saving it will automatically import the connector into our project. This worked fine. As you can see here, it's listing all the operations that are available. So before we start playing around, we need of course first to start configuring the connector. And for that we can go to global elements, click on create, search for the connector, MuleSoft AI Chain, click OK. And now we have here the properties that we need to fill. The first one, LLM type, you can just click on refresh if the drop-down list is not showing any values. So we have multiple LLMs, Anthropic, Azure OpenAI, Grok AI, Mistral, and so on. I will use OpenAI as I already have the API key available. Configuration type, we have two options, configuration JSON and environment variables. In this case, I will use configuration JSON. The file path is where exactly the MuleSoft application can find the JSON file. For the file path, you can again go to macproject.ai on our documentation in the getting start section. If you just scroll down a little bit further until you see the section configuration JSON, it exactly shows you how to add the path to your file. So it's a data with expression that I will just copy here, paste it inside, make sure that it's a data with expression. Okay, the file, I will not call it envvars.json, I don't like it, I will just call it config.json. Okay, so that's the file that now also I need to create and store it into source main resources. The model name which I will use will be GPT-4o, and the rest we can leave as default, like the temperature, the LLM timeouts in seconds, and the maximum tokens. Okay, let's leave that with the default values. Saving the project, and now we need to add the configuration file. Okay, so here in source main resources, let's just create a file. Mine is called config.json. And now we need to provide this specific structure, and that's also explained here on the website. As you can see, you can maybe just copy this one to make it easy, the structure, paste it here inside, and remove everything that you don't need. I will use OpenAI, okay, so I will just remove everything, leave OpenAI, and the OpenAI key that of course I now need to provide. And that's something that I've already prepared. So let me just copy it and then paste it into the application. Okay, save it. Now we have everything already set up for building in order to start working with the project and build a new agent. So I would say let's just add a listener. Okay, so HTTP listener, very first step, because we need to expose, of course, an API. I will use also here the default values, clicking on plus, let's leave port 8081, it will run locally on my machine, HTTPS protocol, all fine. And as path, we can add, for example, API/API/prompt, okay? So now the HTTP listener has been configured. Now the most fun part is our connector. As I have already explained in the beginning, we have multiple operations available. So all those operations are also documented on the website itself. So if you go to MuleSoft AI Chain section, supported operation, all those operations like agent, chat, embeddings, RAG, sentiment, and tools are documented here. With screenshots, with example configurations and everything. So I would say let's start with the very simple operation, and that's chat answer prompt. Okay, so I will drag and drop the connector into our flow, and as we have already configured the connector, we don't have it anymore. We just need to provide the reference. This happened automatically. And the only input required here is the prompt itself. So how do we provide the prompt? We will provide it as payload. In my case, I will provide it as payload.prompt. Okay, so that means I need to provide this JSON payload whenever I call my API. I think that's fine for now, and maybe let's also add a logger. And the logger should just log the complete payloads. Okay, and let's add also another logger and log the attributes. so that you can see what exactly is coming back from the connector. So it's not just a payload, but we have also with this newest release added some additional metadata like token inputs, token output. So that's a really good way in for controlling the amount of tokens that are being consumed for your agent. I think that we have everything already set up. We can just right click on the project and run the project and wait for it to start. Alright, the application is now running locally and exposing an endpoint on port 8081. And now as next step, let's prepare a simple request with Postman to test our API or to test our agent. So now in Postman, we can just build a very simple request. We have an endpoint that is exposed on localhost and port 8081. So let's here create a post request, say local host 8081. The path is API / prompt. That's how we have configured the HTTP listener. And we know that we need to provide a body. In our case, we will use JSON because we need to provide a JSON object that will contain the prompt. Prompt key, and the value can be any text. Let me just make sure that I add here the quotes. Okay, and I can, let's say, hello, my name is Michael. Okay, let's see, the application here is running. I have restarted it in debug mode so that we can really debug not just the connector but also the response and see what kind of attributes are being returned. So I will make the call. Okay, so here in the debug mode we can see that we have received already a payload. So if I go here and say return the payload, then if clicking on evaluate, you can see that it's being returned as application JSON. So that's something that has been released now or changed with the newest release. Before that release, in our earlier or older version, you had to manually transform the response into JSON format so that you can use it on your front end. Now this is happening automatically, or basically that's what the connector is already doing. So there is no need to transform the response. It will automatically be returned, as you can see here, as a JSON object with response as the key, and then we have the string. Okay, in this case, hello Michael, how can I assist you today? So that's how the response looks like. And when we go to the attributes, we can also see that we have here a couple of attributes that are returned. Let me also just here go to attributes, evaluate, and we can see that there is one attribute called token usage that is now being returned. That's also a new feature that has been added here. And using the attributes, we can see what's the input count of our tokens. So how many tokens have been used as an input, how many tokens have been used for the output, and the total token amount, which came back with the response. Okay, so the total amount, and that's really nice if you want to use this kind of data to manage the cost, okay, because calling APIs, making API calls can be expensive, of course, depending on how much tokens will be consumed. So using the attributes that are now being returned, you can use it to fine-tune what should be the maximum amount of inputs that you want to use, that you want to allow, and so on. And we can even add policies using the tokens to manage the token consumption, which is really nice. Okay, so in attributes dot token usage, you can now get the input token, output token, and the total count, which is a really nice feature. So if I just finish the process and we go back to Postman, you can see the response, code 200. So we get this response, this JSON response as an object with the string, hello, Michael, how can I assist you? So that was a very, very easy use case. If you go back to the application, you can see that I have used here chat answer prompt. So let me here now stop the application. So it is really easy to build an agent with a simple chat functionality like here. And what is one of the main benefits that the MuleSoft AI Chain Connector brings? So if we go back to the global elements and we configure the connector, I can now, or before I do this, I can of course extend this flow. I can add multiple steps, multiple actions and operations, and I can create a really sophisticated agent, okay? But what if in future I want to change the LLM provider because OpenAI maybe is too expensive, or there is another AI or another LLM that might be a better solution. So you want to change without having to refactor all your code. And this is possible with the MuleSoft AI Chain Connector because we can just click on edit and now we can change the LLM. So let's say I will switch to Anthropic. Of course, I now need to change the model name because there is no model name GPT for Anthropic. They use different model names. And I will use Claude 3 Sonnet, for example. Click on OK, save it. And now, of course, I need also to provide the API key. At the moment, I only have the API key for OpenAI. So let me extend this config.json file and also add here the Anthropic key. Okay, so now in this JSON file, I have now Anthropic added with the Anthropic key, saving it, closing the file, going back to the flow, and I can now run the same application again. So that's the only change that I made. Okay, the application is deployed. I'm going back to Postman. I can do exactly the same call. And now let's see what we will get back. So we will see the response. Hello, Michael. It's nice to meet you. I'm Claude, an AI assistant created by Anthropic. How are you doing today? So that's really amazing. Okay, we can build sophisticated agents without the need to really know what happens in the backend. How do we call the API specification from OpenAI or from Anthropic? We have reduced all the complexity so that you don't need to do this. Everything is handled out of the box using the connector. The only thing that you need to do, of course, is to provide inputs like the API key and the operation that you want to use. Okay? So in the last part of this session, I will just briefly go through every single operation. Okay, so that you have a good understanding what these operations are all about and what kind of use cases you can build. Okay, so the flow that we just built using chat answer prompt is a really simple one where we just provided an input, which is payload prompt. It can be just any text, it can be a question, and the LLM will answer accordingly. Okay, but if you want your LLM to have access to your historical conversations, for example, access to your last 10 questions or prompts that you have provided, then you would use chat answer prompt with memory, where you can provide inputs like what should be the maximum amount of questions that should be stored in a memory that you need to provide, that will be created with the connector, so that your LLM has access to this information. This is really useful if you want to have some kind of state management, okay, or if you want to make sure that the LLM has always a little bit more context by providing historical conversations. Okay. Then we have agent defined prompt. That's a really nice one if you want to fine tune your agent and make sure that you can provide it with instructions how to behave, for example. The data set here is your input, which can be any text. It can be, for example, a feedback that you as a customer want to provide to an agent. The template would be where you explain or where you let the agent know what he exactly is, okay, what his responsibility is. It could be, for example, that the template would be you are a customer satisfaction agent and your task is to analyze feedback that you receive. And the instructions would be what exactly the agent should do if feedback is received. For example, if you receive negative feedback, please apologize on behalf of the company. That's one way of making sure how to fine-tune your agent and how to behave in specific scenarios. Okay, so that's the agent defined prompt template operation. Then we have multiple embedding operations. You have seen them in one of the last videos or demos that I've made, which is available on YouTube. That's the local knowledge store demo. So I will link it here down so that you can have access to it. And that's really nice if you want to implement retrieval augmented operation workflows, or just short for RAG operations. Use cases like you have LLMs that usually have access to public knowledge because they have been trained with a lot of public data, but you want your LLM also to have access to private local data, and then you can implement those local knowledge stores with embeddings. You usually start with embedding new store, where you just create a store by providing a name. Then you can add documents to the store, which can be file-based, can be a text file, PDF file, JSON file, markdown file, but you can also use embedding add folders to store, where you can provide a folder that contains multiple documents, can be 50, can be 100 documents, and those will be automatically chunked, embedded, and added to your local knowledge store. Okay. Then we have get embedding get info from store. That's in the end the retrieval process, where you can configure any LLM that we provide with that we support with the connector, that will access the information from the store and respond accordingly. So depending on what your prompt will be, that's the retrieval process. We also have another retrieval process, a simplified one, which is called embedding query from store. And the difference between embedding query from store and get info from store is that here no LLM is used. So here the text search or the query is based on text only. So the prompt that you provide will be embedded and will be used to query the information from your local knowledge store. We have also multiple image operations, like generate an image, read an image and understand what kind of image it is, read an image that might be a scanned document. Then we have RAG load document operation, very similar to the embedding ones. That's a single document that works ad hoc. So that means you provide a request, a document, and with the document you additionally provide your context or your prompt, where you say, that's my document, it's a PDF file, please go through it, analyze it, and respond with a summary. Okay, so that means you need to provide the document with your question, with your prompt. That's a single operation for very simplified RAG operations. We have sentiment analysis operations, if you want to analyze the sentiment of any text, for example. And we have the tools AI service, which is also really nice one if you want your LLM to have access to local API specifications, so that it can call a local API. It can be MuleSoft system API, for example, and retrieve data from a backend system like SAP, like Salesforce, and so on. And I will also link a demo to that specific operation here into this video, so that you can have access to it. Okay, so that was it, a short summary about our MuleSoft AI Chain Connector version 0.3.0. Many more features will come into the future, so stay up to date, follow our channel, and speak to you soon again.